Hello friends, let's take a look at the review. This is one of those videos where you should only watch the parts that you absolutely need to. This first part has kind of wording that's different than what we're used to. It says given a 3, 4, 5 right triangle. So all that means is that you literally have a triangle with 3, 4, and 5. You know that 5 has to be the hypotenuse because that's the longest side. Theta is the smallest angle, which has to go across from the smallest side, so it goes across from the 3. Exact values means no decimals. So if you label your triangle, this is going to be opposite, adjacent, and hypotenuse. So the sine is going to be opposite over hypotenuse. Cosine is going to be adjacent over hypotenuse. And tangent is going to be opposite over adjacent. Since we weren't given a quadrant, we just assume that all of them are positive. So for sine 2 theta, I'm going to look at my formula, and it is to take 2 times the sine of theta times the cosine of theta. So for us, that's 2 times 3/5 times 4/5. And I'm going to do that on my calculator, and I'm going to hit math, enter, enter when I'm done, so that it reduces my fraction and gives me the right answer. The formula that I'm going to use here, and this is the one where you have options, which is weird. I'm going to do cosine squared minus sine squared. My cosine, and I'm just stealing these numbers from up here. I already found the pieces I need. So my cosine is going to be 4/5 squared, and my sine is going to be 3/4 squared. So make sure you're using parentheses there to get the whole thing squared properly. And I'm getting 7/25. And then my tangent for my double angle formula, when I look on the sheet, is going to take 2 times the tangent over 1 minus the tangent squared. So again, using the tangent from above, that's going to be 2 times 3/4 over 1 minus 3/4 squared. So this is a lot for me to enter onto my calculator. So I just did the top and got that fraction, and then I did the bottom, and I leave them as fractions so I don't like cut off a decimal or anything. And then I can do 3/2 in parentheses divided by 7/16 in parentheses, math, enter, enter, to give me my answer there. So half of what you need to really be working on is just making sure you know how to enter things into your calculator properly. All right, on to the next fun thing. So this is a cosine of something plus something. So I go to my formula sheet and I look for my cosine plus. And the formula is going to be cosine of the first thing times cosine of the second thing minus sine of the first thing times sine of the second thing. Now, cosine theta I can't look up because I don't know what it is. But this is asking for the x at pi halves. So go to your unit circle, find pi halves, find the x, and that's going to be 0. Pi halves, remember, is at the top. The coordinates are 0, 1. Then I'm going to subtract the sine of theta, which I can't look up because I don't know the angle, but the sine of pi halves will be the y value of that top point, which is 1. 0 times anything cancels out. So all I'm left with is negative sine theta times 1, which is just negative sine theta. So simplify simply means like get it down to as small as you can, but because you have a variable, it might be an x or a theta, there's no way to look it up. So here we're looking for exact values of tangent 105. It tells you to use the sum or difference formula. There's a variety of ways to break this down. So kind of maybe try doing it on your own, but the way that I did it was to split it into 60 and 45. It's not the only option. Following the tangent sum formula, because I used a plus, I'm going to take the tangent of the first thing plus the tangent of the second thing over 1 minus, and then the product of those two things, tan 60 and tan 45. So you need to go to your unit circle and find each of those things. If you go to 60 to find the tangent, you're going to find root 3. Plus, if you go to the tan of 45 and if you go to 45 and you look for the tan, you're going to get a 1. On the bottom, I have 1 minus as part of the formula. And then I just found the two tangents. This one is root 3. This one is 1. So their product is just going to be root 3. And these are the ones where I blew your brains away by making you go through the rationalizing and simplifying. And then I had a lot of guilt, so I decided that we would just stop here. So this is what your answer will look like. And it'll be a lot of combinations of root 3s and 1s and all that kind of stuff. Let's tackle the next one. So here I have a tangent, and you can see they're added. So I'm going to be using my addition formulas again. But I'm back to simplifying. It doesn't say to find a value. It says to simplify. And I see that there's an x in this problem. So I'm probably going to end up with an x in my answer. So I follow the tangent plus formula. So I'm going to have the tangent of the first thing plus the tangent of the second over 1 minus their product. And I'm just filling that in. I can't look up tangent x, so that's going to stay that way. But I can look up the tangent at pi. So think about it. Pi is over here, -1, 0, and tangent is the y over the x, so 0 over -1. And down here, I'll have 1 minus the tangent of x times the tangent at pi, which we just have found to be 0. So obviously on the top, tangent plus nothing is tangent, and on the bottom, 1 minus 0 is 1. So when I simplify, my final answer is just going to be the tangent of x. So here it says to find the exact value. That's going to mean that I need to split it up so that I can find a number. So of course, this one's asking me to find the value, meaning number, rather than simplifying, meaning I might have an x still. So we've talked about how to do this. And what I do is I just think of like what comes to mind to make 5. A 2 plus a 3. And then I see if they can reduce. 2 over 12 would reduce to 1/6 pi. 3 over 12 would reduce to pi fourths. So these both reduce to something that's on the circle, which means I can go ahead and use that. So I'm trying to find the sign of, and I split it up into pi over 6 plus pi over 4. So I go to my yellow card, I find the formula. It tells me to take the sine of the first thing times the cosine of the second plus the cosine of the first times the sine of the second. Now I go to pi over 6 and find the y. Go to pi over 4 and find the x. Then go to pi over 6, find the x. Go to pi over 4, find the y. When I find those values, the words sine and cosine disappear from my work because this is saying go here, find this. Once you find it, it's just a number. So at pi over 6, go to pi over 6, look at pi over 6 on your unit circle, and you're going to end up finding the sine to be 1/2. And the cosine at pi fourths is root 2 over 2. Now it's asking you to go back to pi over 6 and find the x value. So at pi over 6, the x value is root 3 over 2. And at pi over 4, the sine or y value is root 2 over 2. So multiplying the first two, I get root 2 over 4. Multiplying the second two, because they're both under the radical, they can multiply to become root 6 over 4. And then with these, we write our answers with just one denominator since it's the same. And so my answer would look like this. Now, if you looked at the answer key online or on the board, I had written these in the opposite order to begin with, but it's adding, so it doesn't matter. Like 2 plus 5 and 5 plus 2, they make the same thing. And so my answer here is root 2 plus root 6 over 4. And on the other answer key, it's flip-flopped, root 6 plus root 2. But since I'm adding, the order doesn't matter, and so both of those ways would be right. So here I'm looking for exact value. This problem makes me pretty unhappy, but there is one similar to this on the test, so I want to make sure that you know how to do it. The reason it makes me unhappy is my work did not fit on the page. So as soon as you see this monkey business, you know that you're trying to figure out what quadrant you're in. So if you think about your unit circle, pi over halves is at the top and pi is over here. You're looking for the angle between those two. So as you travel around, in between those two is going to be over here in quadrant 2. So that's what that information is always telling you, is which quadrant should you draw your triangle into. This part will always tell you 2 pieces. In this case, because it's tangent, it's opposite over adjacent. So I have a 5 and I have a 6. And one of them has to be negative because my tangent's negative. Well, in that quadrant, which one is negative? I'm making this 5 worse. The negative one would be the 6 because you're going left. What I don't know is my hypotenuse. I know the opposite, I know the adjacent. So I have to do 5 squared plus 6 squared. I don't really care about the negative because it's going to go away when I square it. And then when I do that, I end up with a 25 plus a 36. So I get h squared equals 61. So unfortunately, h equals root 61. Now the hypotenuse is never negative, so it's going to just be root 61. And no perfect squares go into 61. So I can't break it down or reduce it. So I know that I'm going to need to find all of these. I'm going to need to know the sine of this angle, the cosine, and the tangent, because those are the pieces that you plug into those formulas. So look at my triangle. The sine is going to be opposite over hypotenuse. Now, normally I would rationalize that, but I'm going to wait and see if I really, like if I rationalize it now and then I plug it into the formula, I might end up having to rationalize it a second time, and nobody wants that. So I'm going to actually just leave it like this until I'm done. And then at the end, if I have to rationalize it, I'll do it then. So the cosine is adjacent over hypotenuse. Same thinking, leave it alone. And then the tangent's going to be my opposite over my adjacent. So the negative 5, 6, which we knew because it was already given to us up at the beginning. So these are going to be my 3 pieces to actually finally answer this question. So the first thing it wants is the sine of 2x. So I use my double angle formula, which is 2 sine x cosine x. So in this problem, it's going to be 2 times sine and then times cosine. Sorry, my negative got a little weird there. So actually the whole entire thing got a little weird. So let's try that again. Okay, so here's why leaving the root alone actually worked out fine. Because if you think of this as 2 over 1, the square root of 61 is going to get multiplied by another square root of 61, which is really just going to get rid of the square root, because you're squaring a square root. So I end up with multiplying all those top numbers together. So 2 times 5 times negative 6. I'm looking at my answer key feeling like it's wrong. And it is. So if I multiply these all together, I end up with a negative, I'm trying to find room, 60 over 61. And that is going to be, excuse me, my answer to, it's really not a video unless I start coughing at some point. That's going to be my answer to the sine of 2 theta, or 2x. So then I need to do cosine, because it's a multi-piece question. And to do cosine of 2x, I use my formula cosine squared minus sine squared. Then I plug in my cosine, which I look over to the left, and it was this. And I'm going to square it. And then minus my sine, which was this. And that gets squared as well. So you can see again why it's no big deal to leave the square root on the bottom, because when you square it, the top would become a positive 36 because the square gets rid of the negative. And on the bottom, I'd end up with a regular 61 because you're squaring a square root again. On the right, 5 squared, and on the bottom, 61. Since they are alike, and you could certainly do this on your calculator, however much you need to feel comfortable, I'd end up with 11 over 61. And then I get to tangent, round 3, and I go to my formula again, and I look for my tangent of 2x, which is 2 times tan x over 1 minus the tangent squared. So I go to my numbers over on the left. 2 times the tangent value over 1 minus that tangent value squared. So again, you have to be really careful with all the parentheses and all that jibber jabber. $11 over 36 on the bottom. So use your calculator until you can get that. Then I'm going to take this fraction divided by this fraction on my calculator. And when I'm completely finished, I get negative 60 over 11. So again, big calculator thing. Just keep trying. Number 7 on here, we're just not doing because we didn't do half angle formulas. So see you later. All right. So 165, how can you get 165? It's telling you what to do, sum or difference. You can do a variety of things. The first thing that came to my mind was to add 120 plus 45 to make my 165. Then I just follow my formula. The formula says to take the cosine of the first thing times the cosine of the second minus the sine of the first thing times the sine of the second. These are numbers I can find on the unit circle, so that's what I do. I go to 120, so look at your little yellow circle, go to 120, find the cosine. Go to 45, find the cosine or x. Go to sine, at 120, find the sine, which is the y value. So at 120, my sine's going to be root 3 over 2. And then go to 45 and find the sine or the y value, which should be root 2 over 2. These are the ones where we always get like root 2 or root 6 over 4 constantly. And this is no different. These two will multiply to be negative square root 2 over 4, and then minus because of the formula. These two multiply to be square root 6 over 4. So our answer would get written as negative root 2 minus root 6 all over 4, and that'll be that. Okay, so these next two are similar to each other, practicing the sum and difference formulas, but they're kind of a bummer because the first, I'm going to go down here across this off just because that makes me happy before I do all this work. I have to know all the, the certain pieces, and I'm going to have to, based on the fact that I see this, I'm going to probably have to draw some triangles to figure it out. So the first thing I'm going to do is see what I'm doing. I'm taking the sine of A plus B. So I'm going to go to my formula sheet and find out what that requires me to know. I need to know sine A times cosine B plus cosine A times sine B. So there's 4 things I need to know. And unfortunately, I only know 2 of them. I know the sine of A and the cosine of B. So let's at least put in what we know. I know that the sine of A is 2/3, so I'll write that in for sine of A. I know from over here that the cosine of B is negative 3/4, so that's going to be negative 3/4 in there. What I don't know is the cosine of A and then the sine of B. So let me take this information about triangle A and figure it out. The quadrant I'm in, if I'm between pi halves and pi, that's going to put me in quadrant 2 with a sine opposite over hypotenuse of 2 over 3. I'm going to go ahead and do Pythagorean Theorem. I don't know the x. I know it'll be negative because I'm going to be going in to the left to get to quadrant 2. So when I draw my triangle for A, I'm going to end up with x squared plus 2 squared equals 3 squared. So after I do the work, x is going to equal root 5, but it will be negative in order to go into that quadrant. So if this is opposite, hypotenuse, and adjacent, and I need the cosine of A to fill in here, the cosine will be the adjacent over the hypotenuse. So unfortunately, I have to do the same kind of thing for B. So I'm going to look over here and take my B info. In order to be, get it, in between pi and 3 pi halves, I'm going to be in quadrant 3. Cosine tells me adjacent over hypotenuse, so this is going to be 3 over 4. I'm going negative to get here, and I'm actually going to be going negative to go down into that quadrant as well. So I draw my triangle, and I'm going to be doing 3 squared plus y squared equals 4 squared. Doing that math, I get y squared equals 7. So I get root 7, but again, it'll be a negative to be into this quadrant because I'm going left and then down. So here's my adjacent, opposite, hypotenuse, and the thing that I need here is the sine from that. So the sine from that will be the opposite, which is negative root 7, over the hypotenuse, which is 4. Bleh. So that means that I just erased my 4. That I'm going to multiply these two, which will give me negative 6 over 12. And then these two, the negatives will cancel, so I'll have a plus. And because they're both under the root, I can go ahead and multiply them. No perfect square goes into 35, so that'll stay. And then this is over a 12. So I'm going to go ahead and write, sorry, I was just thinking something. I'm going to go ahead and write my answer as negative 6 plus root 35 all over 12, and avoid the temptation of dividing the 6 and the 12, because again, I always talk about triangle reducing, and it would have to come out of all three things, and that 6 can't be divided out of the root 35. So that would be my final answers, the negative 6 plus root 35, which means I need to look back at my little picture over here. We're taking a break. I know you need a break anyway, because I did a answer key on paper, and you guys will be really surprised to hear that I made a little mistake that I want to correct. And so I'm obsessing about it and doing it now during your video just so it can be an even longer video. So just talk amongst yourselves at your math party, your viewing party. All right, I'm back. Okay, hang in there. This is going to be the same thing. So on the quiz, you're going to be doing all these things. You're just not going to be doing them as much. Like, this is practice, and we're working on it for 2 days. So that's why there's so much repetition. But it's the same kind of setup. So this time I'm starting with, oopsies, cosine of A minus B. So I'm going to go ahead and write out my formula and think, okay, the cosine subtraction formula will start with the cosine of A times the cosine of B. It'll change to addition, and then be the sine of A times the sine of B. What do I already know from these 4 pieces to my puzzle? Well, I know the sine of A is 3/4, so that goes here. And I know the cosine of B is 2/5, it looks like. I wrote all over it. So that goes there. Okay, so what I don't know is cosine A or sine B. So I'm going to do what we did before again and use this information to figure it out. So from 0 to 2 pi halves, 0 to pi halves is going to put me in quadrant 1. Sine is opposite over hypotenuse. And just like this one up above, we had the same kind of scenario. This is going to be my x. In this case, it'll be positive, though, because I'm going to the right. So x squared plus 3 squared has to equal 4 squared. So I'm going to end up with root 7 again. But in this problem, it is going to be, positive. So my cosine, since this is opposite adjacent hypotenuse, my cosine is going to be root 7 over my hypotenuse, which is 4. Let's figure out sine b using our b information. 3 halves to 2 pi is actually going to put me in quadrant 4. And the cosine, I can't even see it. I've written all over everything. There we go. The cosine is going to be adjacent over hypotenuse. We don't know the y, but it will be going down, so it will be negative. So y squared plus 2 squared equals 5 squared. So we're going to get y squared equals 21, and y is going to equal root 21, but be negative. That is my opposite side. So when I need the sine of b, I need my opposite over hypotenuse, which is going to be that 5. Okie dokie. So here, the 2 and the root 7 don't mix, but they make a 20 on the bottom then. Here, I get a negative and then a 3, a root 21 over 20 on the bottom. So when I write those together as one thing, I'll have a 20 on the bottom. I'll have a 2 root 7 minus 3 root 21. And there's nothing I can do about that because neither one of those comes out as a perfect square. And you can't add them together because they're not alike. Meaning they don't have the same thing under the radical, if that makes sense. Even if it doesn't make sense, that's how it works. All right. I am filling in my answer key again. Okay. So, oh, thank goodness. This last part looks complicated, but it's actually really easy. So, what you want to do is look at the pattern. This has a pattern of, two different things. So, I have the sine of u, let's say, which is going to be my 15 pi 11ths, times cosine b, which is my other 4 pi 11ths, minus the cosine of u times the sine of v. So I go to my yellow card and I find that that is the pattern that matches the formula for sine of u minus v. So for me, in this case, it would be the sine of 15 pi over 11 minus 4 pi over 11. Well, I go ahead and subtract them, and I get 11 pi over 11. So I end up with the sine of pi, which is actually something I can actually look up, which is why this is asking you for a value. And so if I look up the sine at pi, which means the y, I actually would get a value of 0. Because pi is over here, and my coordinate would be negative 1, 0, and that second value is my sine. Winding down. So what does this look like? This is the cosine of something times the cosine of something different minus the sine of the first thing, because these two match, times the sine of the second thing, because these two match. So look at your notes sheet, look at the formulas. That is the that is the formula for the cosine of u plus v. So I'd be looking at the cosine of my first thing plus my second thing. Adding them together, I'd be looking at the cosine of 10 pi over 16. So this one, I actually can't do anything else with using my unit circle because I get 5 over 8 when I reduce that, and that's not on my unit circle. So I'm done. The moment you've been waiting for, my friends, the grand finale, the very last problem. And it looks hideous, but it's not. It's the tangent of something minus the tangent of something different over 1 plus the product of their tangents. So when I look that up, that is going to come out to be the formula for the tangent of one thing minus the other. And in this case, my one thing is a 7 pi eighths minus the other, which is a pi eighths. So I end up with the tangent of 6 pi over 8, which reduces to 3 pi over 4. I go to my unit circle. This one I can look up, and my answer is -1. So I actually think there was some kind of a typo in this second one because it was supposed to come out to be something I could find on the unit circle, but whatevs, who cares? So at this point, what I would suggest is you just watch the parts you don't feel as confident about so that you can be super successful, because the quiz is going to be a lot like this, just not as long. So have a great day, you guys, and I will see you tomorrow.